Alright, welcome to my video. This is for Foundations Math 20, Chapter 4. And we're just kind of going back doing some review of sine law, cosine law. We left off with the ambiguous case and situational problems is the last thing to do. So we're just going to go back do some review, get refreshed because it's been a while since the school's shut down. So exploring the primary trig ratios of obtuse angles. So you will remember from our sine law, so we have the sine A over the sine of the angle A is equal to sine B over the sine of B, and sine C over sine of angle C. So we use the sine law whenever we have this information and we're missing one piece of the puzzle. There are different uses of sine law, and we'll look at a couple examples. Cosine law, we have the three different versions of the formula, right, which are all basically the same depending on the side that we're trying to find. So if we're trying to find side B, then we are going to look at side A squared plus side C squared minus 2 times B times C times the cos of angle B, because it's opposite the side that we're trying to find. Okay. And remember that an oblique triangle is a triangle that doesn't contain a 90-degree angle. So we will remember from this slide, applying the sine and cosine law, that for all triangles that involve cosine law, that the cosine of the angles that are greater than 90 are the inverse of the angle, and for the sine of the angle, the complementary angles are exactly the same values. So when we have a sine of some angle, then the sine of 180 minus that angle is the same identity. So if we took the sine of 45 degrees, this would be the same value as 180 degrees minus 45 degrees, which is, off the top of my head, I believe it's root 2 over 2, and whatever that is a decimal. You'll have to use a calculator to figure that out. Now, when we do the cosine of the angle, if we were to do the cos of 45, then we would have the cos of 180 minus 45 degrees. Okay. Except that now our answer, whatever the cos of 45 is a decimal, our answer will be negative that value. Make sense? Okay, so that's just a bit of a review. Let's go to the next slide down. And okay, so we're going to do a couple examples of using sine law and cosine law just to refresh ourselves. So we have a triangle here and we want to find a measure of angle A. So we're looking for this angle A here to the 10th of a degree. So we know that side B, opposite angle B, is 40 centimeters. And we know that side A, opposite angle A, is 65 centimeters. Right? Do we know how much angle A is? No. Right? Do we know how much angle C is?
No.
No, so we don't have enough information at the moment to solve the equation. So we have to, we don't know those angles, so we're not going to use the cosine law. But I do note that this angle B that I have, I also know the side opposite to it. Well, if I know the angle and I know the side opposite to it, I can easily find the angle for any other side that I know. Right, so what we're going to use is we're going to use the sine law. So in this equation we have side B over the sine of angle B is equal to, and I want to set up a ratio so that it's exactly the same. So on this side we have to have A, side A, because we had side B up on top, over the sine of A on the bottom, just like we had the sine of B on the bottom here. Right. So if we pull these out, what we're going to get is 40 over the sine of, what's the angle? 23 degrees is equal to 65 over the sine of A. Right, so you will remember that when I do this, right, we're going to use our cross multiplication. So what we're trying to find, we are going to put a box around it. Right, and the thing that we're going to multiply, or sorry, that we're going to divide, is we're going to put a dot up here. So these two things are going together, and these two things are going to go together here. Right? So what we have then is we have 65 times the sine of 23, and this will equal 40 times the sine of A. Right? Now, we need to get sine of A all by itself. This is multiplication here. So what's the opposite of multiplication?
Division.
Division, right? So on this side, we're going to divide by 40, and on this side, we're going to divide by 40. Right? Now I have to remember that when you're doing these types of equations, you have to do each part separately. So you have to figure out what the numerator part value is, and then divide by 40. You can't just go 65 divided by 40 and then multiply by the sine of 23. You're going to screw yourself up. Right? So, let's just pull this out. And I'm going to get rid of this so you can see it. So we have the sine of 23 times 65 divided by 40, and we get the sine of A as 0.6349. So the sine of A is 0.6349, blah, 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 whatever on our decimal. Right? So once we have that angle, so on our calculators, when we want to find the angle, we have to take the negative, use our sine -1 button, right, of the decimal 0.6349 to figure out what angle A is. And when we do that, angle A turns out to be, there it is, 39.4153. So we'll call that 39.4 degrees. Right. Now, that means that this angle in here is our 39.4 degrees. Well, that looks like a pretty small angle, right? So you have to remember that that's our reference angle. That's for our angle when we have a acute triangle, so triangles that are less than 90 degrees. But once we have obtuse or oblique triangles that are greater than 90, we have to find the other possible measurement for that angle. So we know that the sine of some angle is equal to 180 degrees minus that angle, that those two values are the same. So in this case we have angle A being 39.4, so we can look at 180 degrees minus 34 degrees, and when we take the sine of that value, we will get the same sine value of 34 degrees. which was 0.6349. Okay, so 180 minus 39.1 or 0.4 leaves us with our other angle of angle A being 140.6, 0.58 rounded up 0.6 to the nearest measurement. Right? Any questions about that?
Nope.
Let's just go and pause this for a minute.